So that does kind of transition into something else I'd said recently was like I compare and just very 30,000 foot view. I compare like Flux to a decentralized AWS because they do nodes, they do storage. Dynex. And initially, my initial thoughts were Dynex is like a decentralized After Effects, an Adobe
or
AE.
D-Wave. Think of it more like probably D-Wave, because obviously D-Wave is doing stuff with quantum computing and stuff. So, and the best way to describe Dynex right now, it's not supercomputer, but it's not quantum computer. It's probably somewhere in the middle at the moment. It's like that almost bridge gap, right? And that's the bit that's really interesting for me, because I've only played with supercomputers. I haven't played with anything to do with quantum computers, right? You've got to be right up there in the industry to be even playing around with that technology at the moment.
Yeah.
It's way too new. So there's only maybe 100, 200 people in the world at the moment that are playing with, quantum computing and stuff on an actual physical level rather than just theoretical. And this is just somewhere in between right now. And the speed is pretty impressive. The way that it will launch, request workers and just run, very, very interesting. Very, very interesting. I mean, if you want to run some tests, I mean, we can certainly run some tests. I've got no issue with that. Everyone's had the warning to be warned that, servers might take a bit of a hit for a second while we're doing testing. But, this is what it's about, showing people what this can do.
So when you put this together and you hit go, essentially it's using all of our mining rigs to compute that algorithm.
Oh yeah, you actually see the output as each miner comes online, does their job, and then finishes and disconnects effectively. So we can definitely run through that. So you can see here, this is my training model, right? This is just to tell it to work out what points where the validation becomes. So you can see here 2060 training data, 2060 labels, which obviously just means it's all formatted inside of the system, and then there's 515 validations that it's got to run before it considers that acceptable.
Okay,
so it runs quite a loop through. I mean, I could jack this up hard, like higher and higher and higher, or the easier way would just be to increase the data size, because then it's infinitely going to scale upwards. And this is all the quantum vector stuff to be able to extract the solve from Dynex, right? So once you send it off to Dynex's system and it returns to the data, obviously the system has to decode that data because it's packed up in like a really small packet size, and then it has to be exploded in order to facilitate reading it out.
Okay.
So, but yeah, I mean, do we want to run this? I mean, right now it's set,
how do you make it go?
So it's set for a million chips. Let's do one better, right? Let's change this. Right. Let's change this a minute. YouTube prediction live. Right. So that's what's going to go on the actual blockchain right now. When I hit go, that's what's going to come up as the job. So it will come up with a tag of GOAT.
Okay.
So that you can actually see that it is running.
See it going on.
So let's go up to the very top. Let's start the process. So it is as simple as, telling it to run through the code. I could tell it to auto do this, but I like to do it one by one so you can see everything generate. You can see it's now generated all the points. 2060 training sets. This is the bit that we've just changed. So it's orange to tell me there's a change that needs activating. Now we're going to so this area is all computing the metrics. So that's once the data has been unpacked, compute it back to me, please. And then, do the precision and all sorts of things. So we're going to run 1,000 data points for now, just as a test run, so you can see what it does. Once you've obviously set this is the bit where you got to wait, right? So you enact this, right? And now it's a case of waiting, because now it's sending the job to the malloc.
Okay.
Right. Saying, you'll see it in a minute, where it will start spitting out where it's converting it for a job. And basically what that does is it packs the job up ready to be distributed to the malloc. The malloc will then send it out to all the pool's mallocs, because nobody connects directly to the Dynex network. They connect off to the pool's mallocs. So you can see here, this is where it's converting it all to Cubo to be sent over to the network. And once it obviously reaches the malloc or pool side, our pool then picks at random X number of devices to facilitate helping with that job. And it will split it out over all the pools. So that it will take 50 from one pool, 20 from another pool, 20 from another pool,
so
maybe
like
10 from another pool.
Yeah.
And yeah, it just tries to even it out. And you'll see now this is it's waiting for workers. So it sent the job. Now it's waiting for the workers to say, hello, I'm here, I'm doing the job. Obviously, once this actually pops up a job number, we'll be able to actually look at the blockchain and on the POUW dashboard and actually see it.
Oh, nice.
Running.